As you move on in the book, you're going to find, because I don't remember it being that unclear, so I think what's going on is just the first part is unclear. So as you move on in the book, you're going to find out that he's actually going to get more clear. As in this chapter on Cauchy Kovalevsky, he's going to get very clear, I think, and compared to what he's doing here. It seems odd what he's doing here. What he's doing here seems to kind of tell you little bits and pieces of things as you're going along, and then all of a sudden he has a big theorem and it doesn't really fit into anything else, and then way later he has some examples, but they're not full-on examples, and then later on he has the full-on example, so it seems a little scattered and all over the place and hard to follow. So there's really three parts, I think, to the whole thing, is how to actually do the methods of solving the first order quasi-linear equations. And that, I think, he's not done a very good job there. And then the other part is to identify when solutions exist, which he talks about quite a bit. But here, you have to use a lot of Calculus 3 to understand why they exist. And at some point, you don't need to use that Calculus 3 to understand why they exist. So I think that part's not as important yet. And finally, how to identify if your solution is unique, because there are cases where you get an infinite number of solutions. So right now, he's just jumping all over the place. Sometimes he's talking about existence, and sometimes he's talking about the methods, and so it's a little messy. But the first section in this chapter, I'd like you just to read it on your own. It's not really, it's a non-section, really. What it does is it just gives you formal definitions of what linear means and quasi-linear, along with some examples. But we did that last time with using Chris Tisdale's website or YouTube videos. And section 2 gives you a few examples on how to find this general solution, but it's messy and scattered. It's not as clear as I think Chris Tisdale's examples or the examples you've seen in Sean's outline here. Definitely that explanation is not as good. If you notice the examples from the book, he really doesn't do too many things that have above two variables unless it's super easy. There's not really a simple three-dimensional problem that he works. So there's no u, x, y, z, for example. So the example from the book, which is example 2.1, I'm going to set it up with our steps. So the first step is to use set up the characteristic equation. So you have dx over x, dy over y, and du over u. And then you take those equations and you form solvable differential equations by cross-multiplying. So if you take the first two equations, you'll get dx over x is equal to dy over y, and you can solve those equations. So you get natural log x equals natural log y plus c1, and that we've done this already, c1 is equal to x over y. And step 4, if you recall, was to isolate the constants. And I put the equations back at the top so you can see them. The next thing you could do is set up the dx over x and the du over u. So you get the same set of equations, or c2 is x over u. Now the way we've been structuring it is we've been saying that that second constant is a function of the first constant. And so we get c2 is x over u, which is f of x over y, or u over x is 1 over f of x, or you can solve for the u. And we did that in class in the in-class assignment. So this is pretty straightforward. So then the general solution is u of xy equals x over f of xy. And that's the set of steps that are the procedure every time you go. I think the stopping point is probably step 3 and 4, where you're trying to solve those equations or isolate those variables so you get something that's solvable. So that's just finding the right trick. And it may not exist. There may not be a trick to actually solve it explicitly. So we've been checking the work. On the quiz next week, I'll ask you just to check your work. There was our equation. I made a mistake actually first time cranking out these derivatives, but ux is calculated. I did it using the quotient rule, bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. and I dropped off some things that was getting a little messy. And uy, I used chain rule. So I have here, or I use product rule, well, actually chain rule because x is a constant. So I have f raised to the -1 of xy, so -1 comes out in front, and then I have a -2 over here, the x just hangs out for the ride. Then I have the inner derivative, which is f prime of x over y, and then that has a chain rule, minus x over y squared, which simplifies down to the bottom. And then you start getting a little worried, because you think, oh, maybe this is not going to work out, and that's supposed to be uy here, not ux. So you have ux and uy. Oh, there's my uy. So I just cleaned up my ux. There's my uy. And that's the nice part about the PowerPoint. I can just take that and start multiplying both sides. So I multiplied both sides by an x on the ux, and I multiplied both sides by the y on the uy, which you can't tell because I just erased the square on the bottom. And those two things drop out when I add them, and I get left with u. So it did work. This is not as messy as it can get. I actually do remember in PDEs turning in homework the size of your Shams outline. I can't do that here because my professor had a grader. I don't have a grader. But yeah, it can get pretty messy when we get to Fourier series and the other series solutions. So this is just the tip of the iceberg. I gave you the homework on page 62, 2.1, A through H. I'm not sure how tractable they are. I looked at them, and you know, some of them have twists in them, like you were talking about right now. Like you look in the back of the book, it doesn't match it. So maybe some more tractable problems are the ones in Shams outline in sections 5.2, 5.3, 5.6, and those are on page 55 through 58. And what's nice about the Shams outline is the solutions are all in there. So since he's still in here, I'll get 2 more books. If they're not that expensive.
Who's Sean? Oh, okay. Then can I buy that?
You can, but I got it for everybody else. So. So they're worked out, but they're not probably worked out with steps like we have here. You know, so, but at least you have an outline of the solution instead of just an answer in the back of the book. And also 2.4. Let me see what that one was, 2.4. I don't know if this is it. No, it's not the right section. I suggest you try 2.4, but it worries me when he says it's not a simple task to find the solution. He says it right in there. It's not a simple task. So give it a shot and see what you can find.
So we're still on chapter 2, right? We are on 3.
We're on 3, yeah.
Okay.
It's just each chapter is like
Yeah.
I'm doing this because I feel like the first few sections don't seem to have, it seems to make more sense going right into the chapter 3 and doing it. So here's another example. This one was a bit tricky. So this comes from page 67 with a lot of gaps in it. And I think that you looked at it, right? This one. So step 1, write down the characteristic equations. Step 2, oh my God, what do we do now? So here's the problem. You have, and I think this is the typical tripping point. You have y's and u's here, and you need to get rid of the u, but you have an x here. Here you have x, y's, and u's, and you have them on both sides of the equation. Here you have x's and y's and u's on all both sides. It's all of them are intertwined with each other, and there seems to be absolutely no hope of getting rid of one from the other. So for a while, I tried tricks like maybe solving for y in one of them and then getting the dx's and dy's on one side and then moving it to the other. And you find that this is a really frustrating exercise.
Can you do d of x plus u?
Yes, in fact, that's what he did. Let me go back to this one because I want to show you another one. You have to use a trick that he used on another one. So let me hold off for a little bit and go back to this one later. Oh, is this the one that we did? I think this is a different one.